Hello everyone, this is Fahad Mirza and I welcome you to the channel. In this video, I am going to show you in a hands-on fashion a new project called as OpenCoconut. This OpenCoconut is an implementation of a very interesting project or paper called as Chain of Thought in the Continuous Space, which I will also explain in very simple words what is happening there. But this project OpenCoconut is based on Hugging Face Transformer and it implements that paper. Let's try to see what exactly is meant by this coconut. If you look at this diagram, this gives you the whole picture and let me try to explain it in very simple words. So all of these large language models are restricted to reason in the language space, where they typically express their reasoning process with a chain of thought to solve a complex reasoning problem. When we say chain of thought, it refers to the method that generates an intermediate reasoning process in language before outputting the final answer. This includes prompting the LLM or training LLM to generate reasoning chains either with supervised fine tuning or reinforcement learning. And it could also mean that it could be classified the tokens in chain of thought into symbols, patterns, and text, and then LLM generates the output. Now, the thing is that this language space, which is not only understood by models but also by the humans, may not always be optimal for reasoning, because at the end of the day, it is the model which is trying to do the reasoning, and model works best in latent space. Latent space is which is understood by the models and not really visible to the humans. For example, most word tokens are primarily for textual coherence and not really essential for reasoning, while some critical tokens require complex planning and pose huge challenges to LLMs. That is where this new paradigm, Coconut, which stands for Chain of Continuous Thought, comes into play. As you can see in this diagram, they are utilizing the last hidden state of the LLM as a representation of the reasoning state, which is called as continuous thought. And then rather than decoding this into a word token, they feed it back to the LLM as a subsequent input embedding directly in continuous space. And then in this paper they have also shared some of the experiments and stuff, but I am more interested in this OpenCoconut. So let's try to get it installed and then we will see how it works, because the good thing is that this person has not only I think the name is Casper Hansen. He has shared the code but also some inference script, so we are going to use that. Let's try to get it installed and we will see how it works. Before that, let me give a huge shout out to Mast Compute who are sponsoring the VM and GPU for this video. If you're looking to rent a GPU on very affordable prices, I will drop the link to their website in video's description. Plus, I'm also going to give you a coupon code of 50% discount on a range of GPUs. This is my Ubuntu system and this is my GPU card, NVIDIA RTX A6000 with 48 GB of VRAM. Let me create a virtual environment and let's wait for it to get created. And by the way, some people say that why I use Conda. You can use Python virtual environment. You don't have to even use any virtual environment. It is just a personal preference, because Conda makes it really easy to manage the virtual environments, because I create more than a dozen different environments every day and then I select few videos out of it. So if I just start installing everything directly on my system, I won't last for long. And Conda is the best tool for me in order to keep everything separate, and that is just a personal choice. Anyway, so that has already created. Let me git clone the repo of OpenCoconut, and then we will install all the prerequisites. And by the way, I will drop the link to this OpenCoconut repo in video's description so that you can also follow it up. Okay, and then let's install all the prerequisites from the root of the repo. This is going to take a couple of minutes. Okay, so everything is installed. Let's clear the screen. Let's go to examples directory and you will see that they have provided this training, inference and evaluation script. Let me quickly show you the inference script first to see what exactly is happening there in VS Code. Okay, so as I mentioned earlier that this OpenCoconut is a Hugging Face transformer implementation. That is why they are importing those transformers libraries and also the OpenCoconut, of course, and then checking what sort of device we are using with version, CPU, CUDA or MPS. And this is the model which you can also find on the Hugging Face with these checkpoints. Then they are getting the tokenizer and streaming um, the tokenizer from it with some of the parameters, and then model is being downloaded with the tokenizer. And this is a prompt which is being used that John cuts his grass to 2 inches. It grows zero point 0.5 inches per month. When it gets to 4 inches, he cuts it back down to 2 inches. It costs $100 to get his grass cut. How much does he pay per year? And then it is generating the output and model is going to print it out. So, and this is just some of the hyperparameters it is using, just 64. We just want a short answer. Okay, so let me go back to my terminal and then let's run it. I'm just going to clear the screen and then I'm going to do infer.py. Infer is for inference. And sorry, one thing I forgot to do is to log into Hugging Face in order to download the model. For that, the command is Hugging Face CLI login, and you would need to go to huggingface.co, log in there, and then from your profile grab the read token, which is a free token. So I already have my read token from Hugging Face, so I'm just going to paste it. Let me quickly do that, and then just press Y here, and login is successful. Okay, now let me run that infer command here, and that is going to download the model first time. Okay, so the model has been downloaded, but so you can ignore this one because I already see that the files have been downloaded. So let me run this infer command again, and it shouldn't load the model. And these are the joys of working at the bleeding edge. You have to encounter and tolerate a lot of these warnings and errors. Anyway, let me run this. There you go. So it says that John pays $300 per year to cut his grass, which is, I think, spot on and quite fast too. So pretty neat project, I would say. Also, if you are looking to do the training, there is also a script for that. Let me show you. So this is a training script. If you want to fine tune it or train it on your own data set, you can also use this as an example boilerplate code. And interestingly enough, behind the scene, they are using this Quen 2.5.5 billion model, which is one of the most performant small model, I would say. So looks quite good. It's a very simple training script with all the um, uh, training arguments which we already have covered on the channel in various videos. Anyway, seems quite interesting. Let me know what do you think about this OpenCoconut. The good thing is that not only we have a paper, but we also have an implementation. It's not that hard to replicate. That's it. If you like the content, please consider subscribing to the channel. If you're already subscribed, please share it among your network as it helps. Thank you for watching.